So, hello everybody, welcome to my session. I am Manuel Bork from Yatta Solutions, and I'm going to talk about testing of Eclipse-based products. So, just a few words to our company. Yatta Solutions is an independent software vendor and a consulting company. We have two business units. One business unit deals with the development of software in software projects, and the other one deals with software tools. And, well, obviously, I am from the second business division. I am the product manager of UML Lab, which is an Eclipse-based RCP and plugin. It's a tool for modeling, code generation, reverse engineering, and so forth. And I prepared a talk which is basically an experience report of our, well, what we learned when we started to build an Eclipse-based product, which is released about 4 to 5 times a year. And I will focus on 3 topics today. So the first topic will be what we call migration testing. So how to ensure that a plugin installation and update process works flawlessly. The second part will be a test, I would call it integration testing, which means testing of larger functionalities that directly affect the user experience. And the third part will be, well, testing of user interfaces. So, well, Eclipse reminds me on a candy store because, well, there are just so many plugins, and, well, we developers, we can install as many as we like into our own Eclipse IDE. But if you install too many, or the wrong ones, which don't play well together, well, the Eclipse installation will become unstable. And when we have a closer look at our download statistics, we see that though we primarily focus on our Eclipse RCP, on our UML Lab RCP, only 25% of our downloads are this RCP, which includes the Java edition and some other plugins. 75% of our downloads are from our update side. So the target of these installations may be anything. And, well, we know this from user feedback and also bug reports, of course, that we have some typical host IDEs, like, of course, for Java Enterprise developers and Java developers, but also some commercial IDEs, like Zen Studio for PHP development. And then you should know that the install operation of a plugin is different to an update process of this plugin. So both are different mechanisms within P2, and each of both has its own pitfalls. So, well, you have to test everything. And what we did, we tested this by hand. And this was really a pain in the ass, because when we were about to release a new product, all we did was to just perform update and install operations of our tooling. And when we detected a bug, well, what had we to do? We had to fix it. We had to wait until the build server, well, build UML Lab, build the update side, build the product, and then we could test again, and we could start from the beginning with the test. So this is a real pain in the ass. So we decided, OK, this has to be done automatically. And, well, we are fans of continuous integration and have a build server. So the idea is, OK, let's write tests that automate this update and install procedures and perform some, well, predefined operations on these installations to ensure that they will work for the customer. And obviously, we learned over time what the problems typically are, so we enhanced this from release to release. So I want to give you some impressions of what we're testing. The first test is about the compatibility of our tools. So we take, as an input for these kind of tests, a predefined set of, well, Eclipse RCPs, like the Java Enterprise Edition RCP or the Zen Studio. And an important point here is that we have to test this against different versions of these RCPs. Because, well, we see this in our download statistics. Every time when there's a new Eclipse release arriving, every time we have a peak in our downloads, because users usually evaluate tools when there is a new Eclipse release. On the other hand, there are our existing customer base, and especially the enterprise customers. They partly stick on older releases of Eclipse. They are not allowed to use, for example, Eclipse 4.2, but they, don't know, need to use Eclipse Helios or Indigo. So what the test basically does is the test installs the UML app from the update side into this existing Eclipse target platform setup, and then performs some assertions, like if the P2 metadata contains specific plugins. And then, well, we call it smoke tests are performed. A smoke test is basically nothing more than what you do when you test a product manually. You just test some certain aspects of the functionality. You don't test everything. You just test some, let's say, showstoppers if it works. And, well, this is done automatically in that case. The same for the update process. As I said, updating is slightly different than installation. So here, in that case, we install some older version of UML app and then perform the update of UML app and its dependencies. Later on, again, the smoke tests. And thirdly, we test if we can update an existing UML app RCP. And in that case, we have to also test if updating the runtime environment works. So these are the three kind of tests that we do automatically on a nightly basis. And, well, the idea is just to write these tests with JUnit, because then we can simply integrate them within our existing build server. And so we get green or red traffic lights in the build server user interface. And, well, programmatically, we then check if the P2 director has installed certain versions of plugins and features. And, well, I can only advise you to do this if you happen to have these scenarios. It's really a big thing which saves you much time. Okay. Now I'd like to talk about testing of functionality. And, well, this is, of course, different from product to product. And what I want to explain here in my talk is not testing of units of source code, but instead I'd like to talk about big functionality. And in our case, as we have a modeling tool, this is about our round-trip engineering. So round-trip engineering basically means you can generate source code out of a model, and if you modify the source code, the model is updated with the changes you did to the source code. And this works in both directions and so forth. And, well, this is the USP of our product. And, of course, as there is no such thing like bug-free software, there happen to be bugs. And it's extremely important, in our opinion, to ensure that once a bug is fixed, it stays fixed for later releases. So it's not a good practice to just, let's say, try to reproduce an issue that a customer has and try to fix it. And, well, later on, it just gets damaged by another refactoring or so forth, because the test creation would be too complex. So what we did is we simplified creation of tests so that our developers can simply create new tests for the things like our round-trip engineering. For example, testing the code generator here is only one line of code. So this statement starts up the complete UML Lab IDE, loads the model that is contained within this model resource, initializes the code generator, generates the code, compiles the code, and makes the code accessible to the unit test. So now we can continue by, for example, loading the created resources via reflection. We can link them. And by doing so, we can also test the, not only, here we test if the code was compiled successfully. Here we can also test the functionality, which means in that case, if an author or if a book becomes an author, if the author is set on a book, then also if you try to access the books of an author, this collection should contain the book itself. So this is called referential integrity in that case, and well, we can test this within the test. Okay, another example, again, only one line of code, in that case for the reverse engineering. What this line does, initializes UML Lab, initializes the reverse engineering, reverse engineers the code, and creates the model. Now we can perform assertions like, well, is the corresponding classifier created, the corresponding properties, and so forth. And well, we use these tests for testing for the test first approach. So when there's a bug report, we can create a small scenario which is able to reproduce the issue. And then we create a test, and our developers try to fix it. And well, even more simple for round-trip engineering, we can just start with source code or a model. It, for example, in the model case, just generates the source code, re-imports the code, and compares both models with each other. So it's very, very simple to create a test, and this is the message. Of course, it's differently between different tools, and it depends on what the USP and the features of your tools are, but it is very, very important to make test creation just as simple as possible. And well, we did this by writing small test frameworks that well, cover these features, and so we can also create tests just right after the customer made the bug report. Okay. Great. Let's talk about the user interface. In the beginning, we tested our user interface manually. And I don't know if you tested something like user interface for the third or fourth time. Of course, you become error blind. You won't see things left or right to your test path. And well, this is error blindness, and it results in big failures for your product. And well, sometimes you just have bugs in the release that you have fixed once before. So it's a real challenge, and it's really important to automate testing also for the user interface. And in our case, we have some special requirements for us, as we have GEF-based diagram editors, which allow the user to create elements by using mouse gestures. We well, have these special requirements on the test framework we use, because this is also handled differently between different operating systems. So we have to ensure that this works under Linux and also under Windows. And well, of course, this is integrated into the complete user interface of Eclipse. And I talked about smoke tests, and this is something that really suits very good for doing smoke tests, because we have our guided tour, which is kind of one path throughout the functionalities of our toolings. And well, if we perform only these tests onto the different installations, and by doing so, we can verify that we have at least no showstoppers in our releases. So this works really great. But how did we achieve it? OK, the first shot was to use SWTbot for this purpose. And SWTbot has the advantage that it can be very simply integrated into JUnit. And what we liked about it was that it allows to create so-called white box tests, which basically means that we can also perform assertions on the internal state of your application. You don't just check if the user interface looks good or looks correctly, but you can also test if, for example, in our case, if the model was correctly changed or due to some user interaction. So this is very important for us. And well, we don't have guys like testers. We are only developers. So as the tests are written like source code, this is quite OK for us. But nevertheless, it's important to have a quite big and deep understanding of the user interface. It's mainly because SWTbot requires you to create very low-level tests. And so, for example, for me, as I'm not a user interface guy, it's very, very difficult to write tests with SWTbot. Well, to simplify test creation, and as this worked quite nicely for the round-trip tests, we decided, of course, to create a small test framework on top of it. But, well, OK, let's have a look at it. Here again, with one line of code, we can initialize UML app and load the corresponding model, load the corresponding diagram, and open the editor, and perform assertions like activating the tool palette, creating elements. This here is then the white box part where we can ensure that the model element really belongs to this visual representation. But we see this is very rudimentary. We use only the palette tooling here, not our mouse gestures. And well, especially the big problem is what we created on top of SWTbot really needs much maintenance work to keep the changes that SWTbot has, because SWTbot is an incubation project without, well, a strong API, but instead we had to use many internal API methods, which of course change. And so this was quite a high effort for us to keep these tests running. Additionally, we had determinism bugs with SWTbot, and yeah, we ended up having only a few tests with this palette and without greater interaction with the Eclipse IDE itself. Yeah, that's why we chose to use Jubula for our testing last year. And I think you know Jubula and what the features of Jubula are. I'd just like to highlight some aspects, like Jubula is for black box testing, which means you don't have to have this deep understanding of the user interface. Well, that's fine on the one hand side, but on the other, we also need these assertions on the logical state of the application. So we also need this white box testing. Jubula is well suited for the test first approach, as you don't need to have the user interface completely implemented, you can start by writing the test. And this, well, has been well proven for our round-trip engineering tests. And of course, it's already deeply integrated into Eclipse. It ships many standard activities, standard test cases. So, well, you don't have to reinvent the wheel for this stuff. Yeah. Initially, as we wanted to create a test that covers the complete guided tour of our product, which is basically a path through all functionalities, or almost all functionalities of our tool, we ended up creating many, many test cases. And, well, the advantage is that these test cases can very simply be reused in new tests. So the effort in this case was, of course, quite high, but we really have something that we can reuse in our other tests. So this is quite nice. Nevertheless, we had some requirements which were not supported by Jubula in the first place. So we had to improve it a little bit for our purposes. Like the tests, when they are executed, they need to identify elements in the user interface. And this identification takes place by using the names, for example, of the classes and so forth. And, well, the current implementation supports using of the controller part of SWT, which means the edit parts. And we have some cases like there, these flyouts above the person class used for model navigation. They are only available as a figure. So we had to make it possible to use the figures for identification purposes. The other thing is this black box approach, as we wanted to ensure the internal state, we added support to invoke any possible method from a test case out of Jubula. And for example, we can now invoke directly JUnit in a test case. So for example, when a new element is created, we can also check if deeply inside the application within the model a real UML classifier exists. So this was important for us. And well, yes, we are about to contribute this. There are still some legal issues with the guy who did it. So we're looking forward to doing this in this year, I hope, at least. Okay. Of course, we integrated Jubula into our build system. This was quite tough, but I think there's a blog post available from the Jubula guys. And, well, they helped us in that case. So we have this up and running. You need to combine many standalone tools, and the timing between these tools is important. And, well, lots of parameterization takes place and so forth. And what another issue is that we scramble after compiling the class names and the method names of the source code or of the compilation result. And of course, this scrambling has to take place on this name matching within Jubula later on. Yeah, but in the end, we get this nice HTML output here. I think, yes, this is the second chapter of our guided tour in that case. And it runs nicely, as I said. Yeah, so we have both SWT and Jubula, and well, we have already started using Jubula for test-first scenarios when there are bugs that well, that influence the complete Eclipse IDE. We can now create tests with Jubula very easily, and of course, other improvements will be implemented with Jubula then. I think I short in time, but just a few tips and tricks. Choose descriptive names for the test units. I think this is very important. You can group these assignments to components mappings in Jubula, group them hierarchically. It makes it simpler to create new tests. And in our point of view, it's very important to have the tests version controlled in combination with the source code. So we export the Jubula tests to XML and check them into the version control system. And well, I don't know what the current state is, but the modularization of these tests didn't work last year, so we ended up having a monolithic structure of our tests here. Okay, so what are my messages? It's important to automate the build and the test process. It's, in our opinion, the only possible way to get a strong code base to allow refactorings. And you can achieve this by creating own small test frameworks. And this is, of course, always a trade-off. But, well, you have to decide on your own if it's worth it. And for us, it was a bigger investment to create the tests. But now every release becomes cheaper for us. So you have to decide this on your own. OK, thank you.